Hello students, this is third question in tutorial 3. The question says, suppose the random variable n representing the number of customers who walk into a boutique on any particular day follows the Poisson distribution with parameter lambda equals to 2. Assume that each customer who visits the boutique will make a purchase with probability 0.8 independent of other customers and independent of value of n. So capital N is the number of customers who walk into a boutique on a particular day. Let x denote the number of customers who make a purchase in a day. So we have to find here expectation of x. So you can see that there are two random variables here. One is n. One random variable is n. N is representing the number of customers who walk into a boutique on a particular day, and it follows what? It follows a Poisson distribution. So we can write here n as n which is following Poisson with parameter 12, right? Parameter lambda equals to 12. Okay, now assume that each customer who visits the boutique will make a purchase with probability 0.8 and independent of other customers and independent the value of n. So that means if two customers are coming, the probability that customer 1 is buying something is independent of the second customer, right? And the first customer will buy with probability 0.8 and similarly the second customer will buy with probability 0.8 independent of the other customer and independent of the capital N. That means independent of the number of customers who walk into a boutique, right? So and how many values x can take? So x can take any value, right? So x can take values in range, x can take values in range 0, 1, 2, 2, yeah, correct. So we know that each customer will make a purchase with probability 0.8 independent of the other customer and independent the value that n takes. So we can say that for given n equals to small n number of customers, the customer make a purchase, right? So x given capital N. So given that the customers are coming to a boutique, how many customers are going to buy a product, right? The number of customers who is going to make a purchase in a day, it will be a binomial random variable with n equals to n, small n, and with probability 0.8, right? So each customer will buy with probability 0.8 or he will not buy with probability 0.2. And how many customers will come when n equals to n, right? So number of customers who are coming to a boutique, in that x are the customers who are buying the product, right? So x given n, it follows a binomial distribution with parameters n and 0.8, right? Now what we have to find here is we have to find the expectation of x. So for that we needed to find the probability that k number of customers will buy a product, right? So probability of that x given probability that k for x is, it is nothing but summation of n goes from 0 to infinity, right? Probability that x equals to k given that capital N equals to small n into probability that, right? So this you know, right? This is the conditional probability formula. So by using that we can find the probability that k number of customers will buy the product, right? That so we know the distributions for x given n and for n, right? So we know for n it follows Poisson distribution and x given n it follows binomial distribution. So it will be summation equals to n from 0 to infinity, correct? So it is n choose k, p to the power k, right, and 1 minus p to the power n minus k. So here p is 0.8, but I am writing it as p only, small p, and here this is Poisson, right? So it is e to the power minus lambda lambda to the power n divided by n factorial. Okay. Now, one more thing we can observe from here is, so when n is less than k, that means number of customers arriving in a boutique are less than the number of customers who are purchasing a product from a boutique. So the probability for that, it will be equals to 0, right? So it's not possible. So here we can say that when n is less than k, then this probability n choose k, p to the power k, 1 minus p to the power n minus k, it is equals to 0. Okay. Now by using that, we can say that at least k number of customers should be there, right? That means at least k number of customers should visit the boutique. So we have to sum it from k, n goes from k to infinity, n choose k, p to the power k, 1 minus p to the power n minus k, then e to the power minus lambda to the power n divided by n factorial. Okay. I have rewritten the same thing here by writing nck, like by expanding this thing. So it will go from k to infinity, n choose k will be n factorial divided by k factorial into n minus k factorial, right? Here it is p to the power k, then 1 minus p to the power n minus k, here e to the power minus lambda to the power n divided by n factorial. Here you can see that n factorial will get cancelled. Okay. Now I will take some constants out. So I will take e to the power minus lambda out. So it will be e to the power minus lambda into I will take lambda to the power k from lambda to the power n constant as well as p to the power k constant. So it will be lambda times p to the power k. Okay. And from here k factorial. So k factorial will be out. So those terms which are not involving n, we are taking it out. So inside the summation it will be n goes from k to infinity. So inside the summation it will be 1 minus p to the power n minus k, right? Into lambda to the power n minus k divided by n minus k factorial, right? So it can be rewritten as e to the power minus lambda p to the power k divided by k factorial. Again here I can write it as n goes from k to infinity, 1 minus p into lambda to the power n minus k divided by n minus k factorial. So this is the previous step I have written here. Now what we have to find is, we have to find the summation. So this summation n equals to k to infinity 1 minus p into lambda to the power n minus k divided by n minus k factorial. Okay. So when n is equals to k, then what will happen? So the denominator will become 0 factorial, numerator will be 1, right? Then for k equals to when n equals to k plus 1, so okay, when it will be k plus 1, denominator will be 1 factorial, numerator will be 1 minus p into lambda, right, divided by 1 factorial. Similarly, next term for k plus 2, it will be 1 minus p into lambda to the whole square divided by what? 2 factorial, and so on. So you can see here, this is the exponential series, right? This is the exponential series. So how can we write exponential series? So we know, or you can say exponential expansion. So this is written as e to the power x, right? E to the power x. So x here is this. So e to the power, because we know that expansion is e to the power x is equals to 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial. So here x is 1 minus p into lambda. So I can write this expansion as e to the power 1 minus p into lambda. Okay, so this is the summation of n from k to infinity 1 minus p into lambda to the power n minus k divided by n minus k factorial. By substituting this value into the above equation, we'll get probability of x equals to k as e to the power minus lambda p to the power k divided by k factorial into the summation is e to the power 1 minus p into lambda. So what it will become, so this e to the power minus lambda, and here it is e to the power 1 minus p into lambda, so it will become e to the power minus lambda p, right, to power minus lambda p, then this is lambda p to the power k and divided by k factorial. So are you able to see this is kind of familiar distribution, right? So this is nothing but e to the power minus lambda to the power k upon k factorial. So it is a Poisson distribution, right? But the difference here is this is the new average. So you can say that x is having a distribution of Poisson with parameter lambda into p. So we know that what is the value of p here? So p is equals to 0.8, right? P is equals to 0.8. You can see here p is equals to 0.8 and lambda is equals to 12. It is given in the question. So that means x is having distribution of Poisson with parameter 0.8 into 12, which is nothing but Poisson 9.6, right? So x is having this distribution 9.6, and we know that expectation of a Poisson, we have to find the expectation of x. So we know the expectation of a Poisson random variable, it is nothing but its parameter, right? So it is nothing but 9.6. So this is the answer for this question. Thank you.